Good evening, everyone, and welcome to today's Amateur Radio Technician class, session number 10. So let's see where we are in respect of our curriculum. As we can see, we are progressing nicely, and we are now in the syllabus on electrical safety. And just a comment about that topic. It should really be safety first. Safety in everything that we do is paramount. However, in amateur radio, perhaps before we could conceptualize the need for safety, we may have needed to go through some of the other concepts to which we will be speaking about under safety. So hence we would have dealt with some electrical principles and some radio frequency principles. And therefore we are now talking about the safety aspects of them. So for us to understand or probably wrap our mind and arms around safety, we would have had to deal with some of the theoretical concepts in respect of amateur radio before we could deal with safety. Last class, we looked at the directional wattmeter, antenna analyzer, and the antenna tuner. We looked at what is a dummy load. We dealt with modulation schemes such as FM, SSB. We looked at the concept of signal bandwidth. We looked at fast scan TV, CW, continuous wave, Morse code. We looked at what an electronic keyer is, and we dealt with a couple of digital modes such as PSK31, as well as packet radio, and we dealt with what ARQ was. We looked into APRS, DMR, and what a talk group is. We also dealt with another piece of software that is used heavily in amateur radio for digital modes, WSJT. We looked at what mesh networks are, and we reviewed two of them, BBHN and AREDN. And we stopped on page number 48 in the No Nonsense Guide. So that's where we are. And we continue today. We did not have any questions from last class. However, just wanted to review a slide just to expound on it a little, or expand on it a little more in respect of the concept of bandwidth. So we did look at the various signals and how much bandwidth they occupy. And we said CW is 150 Hertz of bandwidth or spectrum, SSB 3000 Hertz or 3 kilohertz, and so on. But just as a reference, on the right-hand side, you will see a little diagram that illustrates, from a transportation standpoint, how much space the different means of transportation might occupy on a pathway or on a roadway. Notice the person who is walking is just occupying a small lane. A motorcycle might take up a little bit more of a lane, a car an even wider lane, and a lorry or a big truck like this, much even wider space on the road. So you can conceptualize bandwidth in the same way. You know, you are getting a message from one place to the next, but the amount of space that you occupy in the lane, or the amount of bandwidth or the amount of spectrum that you occupy to get that message across is greater depending on the mode. So depending on the mode of transportation, you occupy a bigger lane or a wider lane on the road or pavement, as the case may be. In the same way, in amateur radio, depending on the mode that we use, we occupy more spectrum to get a message across. Of course, each of the modes has their own advantages in terms of quality, right? So it's the same way a lorry can transport quite a lot of goods and do so, probably air conditioned for fruits and other things, whereas a person will have to hand carry. So each of the modes have their own advantages and disadvantages, but just bear in mind the efficiency or the amount of space occupied by the various modes vary, and you could think of them in terms of modes of transportation. How wide is your lane? How much bandwidth do you occupy? So we said that we're dealing with electrical safety in general. We will be also talking about RF or radio frequency safety, right? So bear in mind, safety, when we're dealing with electrical power, when we're dealing with radio frequency, they can be dangerous. So note that we are saying here that remember we talked about an electric current and all of that. Well, if an electric current were to pass through your body, the human body, there can be some pretty bad effects associated with that. For instance, one, you can get injured by the current flowing through the body, causing heating in the tissues. Also, it can disrupt the electrical functions of cells, and certainly if that electrical signal passes through the heart, I mean, it can certainly disrupt such a significant organ. It can also cause involuntary muscle contractions. So those are some of the effects that a current has as it flows through your body. So the idea is always be mindful of when we are dealing with electrical supplies. And speaking of electrical supplies, in your home, in your house, most of us would have had the opportunity to plug something in. And what we're saying is that for greater or better safety, we should be using 3-wire or 3-prong receptacle outlets and 3-wire or 3-prong plugs. So notice that the plug on the right-hand side has 3, 1, 2, 3 pins. Notice similarly, the receptacle outlets on your wall also has 1, 2, 3 pins as well for contact. So the recommendation here is, why do we use 3 pins? Because the 3rd pin is a ground for safety purposes, right? So just bear that in mind, 3-pin versus 2-pin. That is one of the strong recommendations to improve safety. Also, another thing that could be used in your home, and you might have seen it around where you have probably the kitchen area, the kitchen countertop area where you have a sink where there's water, or maybe in the bathroom area if you have a shaver or hair dryer near to a sink, outside, outdoors where the area may be wet. You may see a receptacle outlet that looks like this, right? It has 2 buttons, there may even be a light and so on. And when it trips, you have to press reset and get back power. And this is considered a GFCI, or ground fault circuit interrupter. Sometimes people just call it ground fault interrupter, right? So this here provides additional safety in case, maybe insulation isn't so good with the appliance, maybe using a kettle, maybe using a drill, and you don't want a human body coming into contact with a live system and getting shocked or having, to suffer from an electric shock. So the GFCI can detect that stray current and trip, and therefore kill the supply to the device. So that's the purpose or the reason why we use GFCIs like these. You might have seen them around, and it's simply ground fault circuit interrupter, GFCI, or ground fault interrupter. Another device, we came across this when we dealt with the electrical theory, the concept of a fuse. And remember, we said a fuse will blow or it will open contact if the current that's passing through it exceeds its rating. So if I have a 2-amp fuse and 3 amps decides to flow through there, the fuse will blow. Similarly, if it was circuit breaker, the circuit breaker will trip, all right? So that's the purpose of a fuse as well as a circuit breaker, to protect you in case there's some sort of a fault. Meaning that if it is that you only expect 2 amperes through the circuit or 15 amperes through the circuit and more flows, that suggests a short circuit or something is wrong. And the fuse is there to protect you. So a fuse is a very important component for electrical safety. In a power supply, and we dealt with power supply circuits when we looked at circuits the first couple of classes, right? So this is just another circuit diagram showing what a power supply circuit might look like. You have an input have 120 volts and you have outputs of, let's say, 5 volts, negative 5 volts, and so on. But the reason we put this up here is to illustrate that power supplies do contain capacitors. And if you remember, when we were dealing with capacitors, we say think of a water circuit and, you know, think of it as a sort of bucket of sorts of storage, right? So just bear in mind that in circuits, we have capacitors that will store a charge. So even though you might have removed or unplugged the device from the wall outlet, don't for one moment believe that there isn't some voltage inside of the device. So just be careful, be mindful that you have things like capacitors inside of devices that even though you switch it off or you unplug it, there may be dangerous voltages and so on inside of the device still because of things such as capacitors. So always be mindful that there are devices, even though unplugged, there might be a voltage inside of there that can zap you. So please bear that in mind in terms of safety. Another aspect of safety, well, electrical related certainly. On the left-hand side here, you see a tower, and on the top there's an antenna. So as hams, we tend to install antennas on towers or poles or masts. But we need to bear in mind, when we install these poles, when we install these masts, we need to do so with safety in mind. Imagine a scenario if it were that the mast were to fall down, right? Let us say, you know, the base gets corroded or, you know, some weather system passes and knocks it down or some other fault that results in the mast falling down. When you install that mast, you need to make sure that if it falls down, it will not come in contact with electrical wires. So one of the rules of thumb that we have for you is make sure that you have at least 10 feet between the nearest electrical line or power line and where that mast may fall. And we say at least, right? Some of us will say, you know, go 20 feet or more if you can, right? Some of us may have that luxury, but try to make sure that you at least 10 feet. If after you put up that pole or where you intend to put it, if it falls, it's going to make contact with that electrical line, very, very, very bad idea, right? Not a good idea at all. I mean, there are things you can do to mitigate, but if that line falls, it's going to pose a danger. It's going to contact the electrical lines, cause a short circuit. It's probably going to cause the circuit fuse to burn out. It will probably affect your entire neighborhood, as well as it becomes dangerous as your metallic tower will become energized. And if you are nearby or someone is nearby, they can receive an electrical shock. And if your cable going to your radio comes off of this antenna tower inside of your house, that could become live. So you see the importance of safety. We need to make sure that we install or perform installations in such a way with safety in mind. So again, minimum of 10 feet factor headroom in terms of if the tower were to fall down between that point and the electrical lines. We also, for the purpose of the technician class, need to be aware what a crank-up tower is, as well as a gin pole. So a crank-up tower is simply a mast that could be raised and lowered. So notice this here has several sections, 1, 2, 3 sections. This antenna could actually go up. And notice it has the extra cabling to allow for the antenna to go up. So the amateur radio operator here will crank this up and operate. And let's say an electrical thunderstorm is coming, or a tropical depression, or a tropical storm, or a hurricane, or something is coming. To protect the system, the best thing would be to lower it to the lowest point, right? So this is a crank-up tower. Costs quite a bit more than a standard straight tower, but the advantage here is that you can lower it to protect the antenna system and the tower. Also on the right-hand side here, a gin pole is this pole that you see on the left-hand side here that allows you to build up a tower. So we have these riggers that are on top of the tower, and they're building the tower section by section, while the device that you use to pull up the next section to put on top of the tower is called a gin pole, right? So that's the gin pole here, and it's used to build up the tower or the mast by pulling up section by section. So it's a little bit early for us to take a break. So let us just go straight into the no nonsense guide. And yes, certainly welcome. Yes, thanks a lot, John. All right, so let's just go straight into the material. Give me 1 second, please. Okay, so this is where we left off the last class, and we said we are dealing with electrical safety. All right, so let us go straight into this material. So remember we said safety first. Safety in all regard, that's most important. So the note here is be safe. When we are using amateur radio equipment, we can come in contact with dangerous voltages and currents. And note here, people have died working on high voltage circuits. So please always be mindful that voltages are present with equipment, and we need to be aware of what those voltages are and where they exist. And they make the point here that as little as 30 volts is considered the lowest voltage that can be dangerous. And also they say 100 milliamperes flowing through the body can cause death. So you should be aware of these things, the safety aspect, most important. Notice they say that these are not very large values, meaning 30 volts and 100 milliamps. All right, so that's just perspective for you. Let's get straight into the question pool. What health hazards is presented by electrical current flowing through the body? Well, we dealt with that on one of the slides in the slide deck, and they're saying all of the following choices are correct. Remember we said that the electrical current could cause injury by heating your tissue. In other words, it could kind of cook you, fry you. All right, so the other thing is that it can disrupt your body's function, the electrical functions of cells. Think of your heart as well. It can cause cardiac arrest. All right, so bear in mind. Also, you can have involuntary muscle contraction. For instance, if you get a shock, let's say you hold on to an electrical line with your hand, that muscle contraction could cause your hand to hold on even tighter to that line. So you want to release your hand, you know you're getting shocked, and you want to release the wire, but guess what? Because you have involuntary muscle contraction, your hand is not able to release, so you continue to get even more shock, right? So imagine that you know you need to release, but you are having involuntary muscle contraction. So we need to learn these as the correct choices for that question, right? So they say to ensure that all of your outlets are properly grounded. So once you're setting up your amateur radio station, make sure there are 3 wire plugs and 3 wire receptacle outlets and that they are properly grounded. All right, so let's go into the question. In the United States, now remember we are doing FCC exams. So our reference point is always the US, right? We may have some little variations in Trinidad and Tobago, but just always bear in mind, that's why we're still dealing with inches and so on, color coding and so on of the United States. All right, in the US, what is connected to the green wire in a 3-wire AC plug? All right, so remember we talked about that 3rd pin being ground? Well, the color of the wire that goes to that 3rd pin happens to be green. So the ground wire going to your receptacle outlet is green in color. So the answer is equipment ground. All right, so the green wire is ground. Next question. What is a good way to guard against electrical shock at your stations? Remember we said we need to protect ourselves. So what are some of the ways? And they tell us all of these choices are correct. So let's deal with all of them. So the first way is to use 3-wire cords and 3-wire plugs. So we made that point in the slide deck, right? So for all alternating current powered equipment, use 3-wire plugs with 3-wire cords, all right? So bear that in mind. That's an important aspect to ensure all your stuff is properly grounded. If not, you might end up being the ground that fault current will try to pass through. And guess what? You might get an electrical shock. They say also connect all alternating current powered equipment to a common safety ground. Again, grounding is important, right? And how you ground is make sure that all of your plugs are grounded. Notice that they recommend here, remember we talked about GFCI or ground fault circuit interrupter or simply ground fault interrupter. Well, they're simply saying use a GFCI or use a ground fault interrupter type plug or device in your home. It will provide additional safety to avoid electrical shocks, right? So the slide deck, we had what that looked like. All right. So they say you need to install fuses or circuit breakers to kill or disconnect power in case the current exceeds the specified value. So here's the question. What is the purpose of a fuse in an electrical circuit? I'm sure most of you are aware. The purpose is to interrupt the power in case of overload or some sort of short circuit that could cause damage. All right, so in an overload, you might have a fire being set, someone might be electrocuted. So you need a fuse to protect the equipment, to protect your property, and most importantly, to protect you, the person. They remind us here that when we have a fuse, remember we said fuse and circuit breakers have a rating. So we talked about a 2 amp fuse or 2 ampere fuse or 15 amp breaker and so on. So whatever fuse that we are replacing, always replace the blown fuse with a fuse of the same type and value. In other words, don't put a 10 amp fuse where there was a 2 amp fuse before. If the manufacturer has and requires a 2 amp fuse, that's the load, make sure you replace it with an equivalent. Putting a higher value could cause fire and could cause failure. So please always remember that. Question, why is it unwise to install a 20 amp fuse in place of a 5 ampere fuse? So why do you not want to do that? The answer, we just said it, the excessive current could cause a fire, right? So always remember, please, equivalent fuse ratings. All right. So they're talking, remember we said Ham's experiment and build stuff. So they're saying if you're building your own equipment, make sure you include fuses in your design. Don't just go and wire up something and don't have a fuse, right? Equipment purchased will most certainly have some sort of fuse or protection. But if you're designing your own, please include it. Question in the question pool. What safety equipment should always be included in home-built equipment that is powered from 120-volt alternating current power circuits? In other words, if you're building a project and you're going to plug it into the wall, what safety equipment should always be included? Well, again, you know that answer. A fuse or a circuit breaker, and it goes in series with the alternating current hot conductor. So that's just a little sophisticated way of telling you you need a fuse or a circuit breaker with the supply, all right? Good. So they remind us that as part of our safety, whenever you're working on equipment, please, please, please be sure to disconnect it from the power lines. You don't want to open up your radio, for instance, anything at all. It could be a fan. It could be anything that you're going to work on. Your fan stopped working, for example. It stops working, you say, let me fix it. You know, maybe it's the capacitor in there I need to change. Why would you open that fan if you haven't unplugged it from the wall, right? If you don't unplug it, you may have live power inside of there and you may go with the screwdriver and try to disconnect the capacitor and you get zapped. Why? Because there's live power inside of there. So do yourself a favor. The first thing you want to do is to disconnect it, at least disconnect it from the power line, unplug it. Right? Notice they say be careful when you're working around capacitors. Why? Because capacitors keep or retain or store an electrical charge. So remember, you have equipment that may be unplugged, but capacitors holding charge, waiting for you. Right? All right, so question in the question pool. What kind of hazard might exist in a power supply when it is turned off and disconnected? We just talked around it and we certainly looked at a slide deck slide on that. So what kind of hazard? Well, you might receive an electrical shock or electric shock. Why? There may be a charge stored in large capacitors. And it could be a pretty serious zap that you can get. It could even knock you out. You can get such a jolt that you end up flying across the room. It can happen like that. So please bear in mind, safety first. All right. Similarly, if you're using batteries to power your amateur radio station, remember, amateur radio operators, we like to be ready for emergencies. So in case we lose power from the electrical lines, we may want to power via 12-volt battery storage. Very highly recommended, especially for emergency communications. But we can also have safety considerations. There may be hazards involved. All right, so let's look at the question in the question pool, and it will tell us what those hazards are. Which of the following is a safety hazard of a 12-volt storage battery? So that's like a battery in your car, for instance, right? That's what a 12-volt storage battery is. Amateur radio operators use batteries similar to that. What's a safety hazard? Well, if you short the terminals, meaning the positive and the negative terminal of the battery, if you short it, let's say you end up putting a spanner across the terminals or a piece of uninsulated wire across the terminal, guess what? You can have that short circuit causing a fire, an explosion. The battery can explode and you can get burned, right? The lead acid, if it's a lead acid type battery, you can get burnt as well from the acid. You can get burnt from the heat generated from that short circuit, that flash that you get. So bear in mind that that is one of the hazards with even batteries, right? You may not get a shock if you touch the battery terminal, 12 volts only, as we probably are aware. Still don't go around touching the terminals, but the hazard that is significant is in case you short the terminals, and shorting means connecting the two terminals together, the positive and the negative. If you do that with some sort of conductor, a very good conductor, you short the terminal, you can have a fire, an explosion, and receive burns. Very dangerous indeed. So safety first. Next question. What can happen if a lead acid storage battery is charged or discharged too quickly? Right, so lead acid storage batteries, for example, what you can find in a vehicle, so a car or a truck and so on, they typically use lead acid batteries. It has liquid sulfuric acid inside of there. So just bear in mind, right, acid in batteries. Well, if you charge it too fast or you discharge it too quickly, meaning you short circuit the battery, this is what can happen. The battery could overheat, it can give off a flammable gas, or it can explode. So again, you don't want to charge or discharge a battery too fast. You know, if it's a 100 ampere hour battery, and it might be rated at how much of a cranking amp, certainly you don't want to short circuit that battery and cause it to overheat or have to give out more current than it is intended to deliver. All right. So let's look at antennas and tower safety. So we talked about electrical safety as being most important, but here's what. Before we go into the antenna safety aspect, let us take a very short break. Please take a stretch, have a bathroom break, get some water, and we'll be back in 2 minutes. Craig Knight, on our online class, could we talk a little later in about half an hour? Oh, yeah, no problem. Okay. Okay, welcome back everyone. And thanks very much, Colin, for your comment. Sorry to hear, I don't know how long ago that was, but Colin tells us that all batteries are dangerous, as he had an experience where an alkaline battery exploded in his face and he spent 4 days being unable to see and he was in the hospital. So sorry to hear about that, Colin, but thank you for sharing that experience. Yes, batteries can be very dangerous, so we need to be mindful. They are chemicals after all, and the electrical voltages present. So let's not take any of it for granted. So thanks for sharing there, Colin. So we continue, and we are looking at antenna and tower safety. All right, so we are saying that antenna safety is also of primary concern to us as amateur radio operators. We always need to be safe when installing the antenna as well as operating the antenna. We made the point earlier on the slide deck that make sure you take a note of where power lines are and stay clear of them, right? So let's go straight into the questions in the question pool. Which of the following is an important safety precaution to observe when putting up an antenna tower? So we're going to do an antenna installation or antenna tower installation to put an antenna up. What is a primary safety precaution or an important safety precaution? The answer is we have to look for and stay clear of any overhead electrical wires. All right, so we dealt with that in the slide deck. We show that it's important that we stay far away from electrical wires. Next question. What is the minimum safe distance from a power line to allow when installing an antenna? So we do have a slide in the slide deck on that. And here's the answer. Enough so that if the antenna falls unexpectedly, no part of it can come closer than 10 feet to the power wires. So remember that rule of thumb, 10 feet minimum. Right? It must not be able to touch the power lines or the pole or anything with respect to the power infrastructure. So 10 feet is your key to remember. All right. Next question. Why should you avoid attaching an antenna to a utility pole? All right. So when you see that question, it's like, why would you even want to do that? Why would you put an antenna on a utility pole? Well, please don't. And the reason is the antenna could contact the high voltage power lines. So please do not try to do that. TNTech will not appreciate it. You could probably be charged. I'm sure it's illegal to do and it's unsafe. So please take that thought out of your mind if it has even occurred to you, all right? But this should be a straightforward question, I would think. All right, so also make sure that when you install your antenna, no one could touch the antenna when you're transmitting, all right? That is true if you're doing an installation in a car as well. I mean, don't make it easy for somebody to go up and touch the antenna. If it's a base station, don't make it easy for someone to go and touch that antenna when you're transmitting, right? Remember, we have RF energy coming out of that antenna, and yes, you can get something known as an RF burn. So please do not try it. Do not touch an antenna when it's transmitting. All right. So you might be saying, but what about a rubber duck antenna on a handheld? Please also don't touch that. I mean, the power levels are much lower and so on. Your body will absorb the RF, but please still do not touch an antenna when transmitting at all. Okay, so here's the question in the question pool. What could happen if a person accidentally, right? And we say accidentally, hopefully you wouldn't deliberately do it. What could happen if a person accidentally touched your antenna while you were transmitting? We just said it. They might receive a painful RF burn. And there may be persons in the audience who would have received such a burn, let's hope inadvertently, and it wasn't too bad, but please bear in mind, do not touch antennas when transmitting. Keep a safe distance away from it. All right. So let's talk about some of the other things that you need to bear in mind when putting up a tower and installing antennas. So we'll just go through the questions, and the questions will give us the information. So we just need to learn these things, right? But many of these things, when you look at it, You'll say, but wait, now that's pretty obvious, right? So let's look at the next question. When should members of a tower team wear a hard hat and safety glasses? So you're probably already thinking, well, all right, that's a kind of no-brainer there. Always, right? So that's the answer. At all times when any work is being done on the tower, you must wear a hard hat and safety glasses. Do not take it off while you are doing the work, right? So when they say when, the answer is at all times when you're doing the work. All right, so here's another one that will teach us something. What is a good precaution to observe before climbing an antenna tower? So remember the slide deck we showed you, antenna towers and so on? Well, someone has to climb that to put up the antenna. Those are often called riggers, right? That's a term that is sometimes used to describe a person who climbs a tower. You say a rigger is climbing the tower to put up the antenna. Remember we showed the gin pole, right? They were using the gin pole, a pair of persons, two of them. You may not have noticed, but they used something to strap themselves onto the tower. So that's what the precaution is. What is a good precaution to observe before climbing an antenna tower? You need to put on a couple of things. Firstly, you need to have an inspected climbing harness, right? It must have been inspected before. It's also called a fall arrestor, and you need to make sure you have on safety glasses. So when you're climbing a tower, make sure that you have these things: a climbing harness, or sometimes called a body harness or safety harness, also called a fall arrestor, as well as safety glasses. So you just need to learn these are things that you need to have when you're climbing a tower. All right, so here's this other, what I like to call, might be obvious question, or if you think about it, you might be able to come up with the answer. Under what circumstances is it safe to climb a tower without a helper or observer? Now, why would you want to go and climb a tower by yourself, right? That's the question here. So under what circumstances is it safe to climb a tower without a helper or an observer? The answer is never. So please do not go and climb a tower by yourself. Even if it's just going up a couple of feet, don't do it. Make sure you tell someone, make sure there's someone there to help you, or there's a watch or somebody to observe you climbing, just in case you get into difficulty, all right? So better to be safe than sorry. So never climb a tower without a helper or an observer. All right, continuing. Which of the following is an important safety rule to remember when using a crank-up tower? So recall in the slide deck, we showed what a crank-up tower is. It had multiple sections. It's telescoped into each other, and they can use a crank and raise it up as necessary and lower it. All right, so they're asking, what safety rule do you want to remember if you're using a crank-up type tower? Right. So what they're saying is this type of tower must not be climbed unless it's retracted or the mechanical safety locking devices have been installed. So for the crank-up towers, do not climb it unless it's fully retracted, meaning all the way down, or these mechanical safety locking devices have been installed. Because if you climb on it and those locking devices are not there, it may very well slide down under you. So those are two things that you need to make sure if you happen to be using a crank-up type tower. All right, so this is another teaching question here. So let's just deal with it. What is the purpose of a safety wire through a turnbuckle used to tension guy lines? So guy lines are the lines that you connect from the tower to the ground to stabilize it, right? So in case wind blows, the tower doesn't lift side to side and so on, right? Those guy wires will what keeps the tower steady, all right? So if you look at the tower, you will see some guy lines going to it. Those are the guy lines that they're referring to. So what is the purpose of a safety wire through the turnbuckle? And the turnbuckle is where that guy wire, let's say, turns and comes back on itself. So the turnbuckle is the eyelet, as it were, that the wire will go over to smoothly turn around, because you don't want that to kink. You don't want the wire to have a sharp kink. So you use something called a turnbuckle to manage that point of connection. So there's a safety wire that goes through the turnbuckle. But what's the purpose of that safety wire? The answer is to prevent the guy line from loosening from vibration. So you just need to learn that there is a safety wire that goes through the turnbuckle for the guy lines, and the purpose is to prevent loosening due to vibration. So simply learn that. All right, so they also make the point here that you should use a gin pole. So we did look at what a gin pole is in the slide deck. We showed a picture of what it looks like connected to a tower. And we said that it's used to help lift up the sections of the tower as the riggers are building it. All right, so let's go straight to the question. What is the purpose of a gin pole? All right, so this is not alcohol we're talking about. This is a device used to raise up or even lower the sections. So that's the answer. To lift tower sections or antennas, right? So when you're installing the tower for the first time, that's what you're going to use, the gin pole, to pull up. It's a mechanical help to help the persons. Otherwise, you'll have people holding onto towers and climbing up the side of the tower with a tower section. You don't want to do that. I mean, you only have 2 arms, right? So the gin pole is a help to help you lift those tower sections onto the antenna. So you could always just refer back to the slide deck and see what the gin pole looks like. So they come to a very important concept that we talked a bit about earlier, grounding, right? So we need to make sure that our tower is grounded. Grounded, grounded, grounded. Make sure you are grounded. Did I say make sure you're grounded? Yes, grounding is extremely important for many reasons. I mean, interference one, but the big one is to make sure you have electrical safety, all right? Note this here, a tower, after all, basically is a big lightning rod. So imagine you just put up a tower in your yard. You have just put up a lightning rod that says to lightning, come, all right? So you need to make sure that that tower is properly grounded. All right, so let's just go through the questions and we'll have a couple teaching moments in it, right? So question, which of the following establishes grounding requirements for an amateur radio tower or antenna? Well, the electrical codes or the local electrical codes is what will establish that. So in Trinidad and Tobago, we have the TTBS electrical code. In the US and other places, you have the NEC, National Electrical Code. Those codes, or the NFPA 70, 90, those codes are the codes that establishes grounding requirements, grounding and bonding and so on. So just be aware that local electrical codes are what specify grounding requirements, all right? What is considered to be a proper grounding method for a tower? All right, so how do we properly ground a tower? Well, the answer will tell us. We need to have separate 8-foot long ground rods for each tower leg, and they need to be bonded to each other. All right, so probably in the next slide deck, we will illustrate what ground rods look like and how you need to do that bonding. But just bear in mind, if you have a tower installed, for each of the legs of those towers, you need to have a separate 8-foot long ground rod. And they also need to be connected to each other or bonded to each other and to the tower, right? So bonding is another most important concept when it talks about grounding. You need to connect each item to each other, and that's bonding. So if you have if you have a 3-legged tower, that means you need to have 3 separate ground rods, 1 for each leg. And then you need to connect them to each other. It's not good enough to just ground each leg to the ground rod. You need to bond all of them by making a connection from each one to the other. And we'll try to illustrate a diagram of that for you probably for the next class. All right. So you need to learn this, 8-foot ground rods for each and bonded to the tower and each other. All right. So next concept, the question is which of the following is true when installing grounding connectors used for lightning protection? Simply, we need to avoid sharp bends. We need to have gentle bends. So in other words, you don't want to kink the ground wire, right? So when they talk about grounding conductors, they're talking about wire used for grounding. So in other words, you need to have the tower grounded to your grounding rod. You need to have wire or ground wire going from the tower to that grounding rod. They call it here grounding conductors. Just make sure when it's run, you don't have any sharp bends. Don't just take it and bend it at 90 degrees, for example. Make sure that they are gentle bends. So the answer is sharp bends must be avoided. Keep them nice and smooth. All right, it's just like, if you're bending PVC pipe, electrical pipe, you notice that they have nice smooth bends. There's no sharp bend. I mean, as a matter of fact, if you have a sharp bend, you'll kink. And it's actually not a bend anymore. That opening will be closed, right? So keep it nice and smooth. Next question. Which of the following is good practice when installing ground wires on a tower for lightning protection? All right. So these are the conductors that you use to go from the tower, for instance, to the grounding rods, right? So they're talking about installing ground wires to ground off a tower for lightning protection, right? So you would put ground rods in the earth, and then you will run ground wire from your tower to those ground rods. So they want to know what's a good practice for those wires. The simple answer is to keep them short and have that connection direct. Don't have it jump into something else and twist it onto something else and so on in between. You want to run that wire from the tower to the ground rod direct, and you want to keep it short. If it only needs to be 3 feet, keep it 3 feet. If it needs to be 6 feet, keep it 6 feet. Do not say, well, I have extra wire, let me use it all. No, keep it as short as possible and direct. All right, so we're dealing with grounding. Next question. What should be done to all external ground rods or earth connections? Well, we kind of dealt with that a little earlier in another way, right? We need to make sure that they are bonded. And bonded is simply connecting the things together using a conductor or a wire. And you need to make sure that they have a sufficiently heavy gauge or thick wire. And you can also use something known as a conductive strap. So those are the two things that are used when you're bonding your ground rods together, either heavy gauge wire or a conductive strap. When you connect those ground rods together, that's called bonding, right? Now, note they say that lightning, apart from coming down your tower and going through the ground wire into the ground rod, into the earth, lightning might also be conducted down your feed line or your transmission line into your station, going to your radio. Remember, your radio, you have feed line, remember, either coaxial or heliax or ladder line or something like that. Your radio is connected to your antenna using feed line. So that is another path that lightning could possibly take to get to your radio equipment. So you don't want to be in front of your radio and lightning strikes and it comes through your feed line and next thing you get a shock associated with that, right? So therefore, there are things that you could do to prevent this or to mitigate. So for instance, there are many devices that are manufactured that can help you to dissipate some of that lightning energy before it gets into your station, right? And it'll dissipate it to ground. All right, so question in the question pool. Which of these precautions should be taken when installing devices for lightning protection in a coaxial cable feed line? All right, so what precautions should you take for coax? The answer is mount all of the protectors on a metal plate that is in turn connected to an external ground rod. So again, we'll try to provide a diagram for you to show what this looks like. So all of the protectors, sometimes they're called polyphase lightning protectors. That's a brand actually. You can use those inline type devices in the coaxial feed line and have that protect your equipment. But they are recommending here that you want to mount all of them on a metal plate and have that grounded, all right? So that is how you mount those protection devices. All right, so we come into radio frequency hazards or radiation exposure, right? So you can be exposed to a safety hazard through radio waves. And they're saying with as little as 50 watts, you may have to conduct what is called an RF exposure evaluation of your amateur radio station. right? So even though they say VHF and UHF radio signals are non-ionizing, remember when we did the radio spectrum, we looked at ionizing radiation and non-ionizing radiation. So even though RF radio frequency is non-ionizing, you will still need to do an exposure evaluation of your station, right? Okay, so these couple of questions talk about the properties of these signals as far as safety goes, but just bear in mind that radio frequency are non-ionizing radiation as opposed to ionizing radiation. We will look back up at the spectrum and find, you know, things, the types of radiation that are ionizing and therefore directly harmful to the body, right? So, question, what type of radiation are VHF and UHF radio signals? We need to know and memorize that it's non-ionizing as opposed to ionizing. So once you're talking about VHF, UHF radio signals, remember, learn that it's non-ionizing radiation. Next question, how does RF radiation differ from ionizing radiation or radioactivity? All right, so notice we are talking about VHF, UHF radio signals. We're not talking about X-rays and gamma rays and so on, right? And those tend to be ionizing. So how does RF radiation in the VHF and UHF spectrum, for example, differ from ionizing radiation? The answer is that the RF radiation from your VHF and UHF signals and so on does not have sufficient energy to cause genetic damage. However, the ionizing radiation from, I guess, you know, X-rays and gamma rays and those types of ionizing radioactivity may cause genetic damage. So just note that your RF that you as an amateur will typically use does not have sufficient energy to result in genetic mutation or genetic damages. But still, note that even small RF energies could be hazardous, right? So let's look at this question to do with when you have to conduct a RF exposure evaluation. What is the maximum power level that an amateur radio station may use at VHF frequencies before an RF exposure evaluation is required? So the answer is 50 watts peak envelope power at the antenna. So in other words, as long as you're not driving more than 50 watts PEP at the antenna, you're not required to do an RF exposure evaluation. But if you go at over or exceed 50 watts, you will need to conduct what is known as an radio frequency exposure evaluation. Right, so the question is, how do you perform an RF exposure evaluation given that you might need to do it if you're running higher power based on the frequency that you're using? All right, so let's go straight into the question and it will give us the answer. Which of the following is an acceptable method to determine that your station complies with the FCC radio frequency exposure regulations? Remember, we're doing FCC exams, right? So these are the things that you need to do or use to calculate your RF exposure. The first one is a calculation based on Bulletin 65 of FCC OET. Right, so you simply have to learn that is where you get the guidance. You can also use a calculation based on computer modeling. There's computer modeling software that can tell you what your RF exposure is. So that's another method that you can use. And the third measure is an instrument called a field strength meter. You can measure field strength using a calibrated piece of equipment to measure what that field strength is to determine your RF exposure. So these are the three ways, and all these three answers are correct for your question in the question pool. Right. What is the definition of duty cycle? Well, let's go to the theory here first, right? So one of the factors when you're doing an exposure evaluation is to consider duty cycle of your transmission. But what exactly is duty cycle, right? So let's talk a bit about that. If I am transmitting for 5 seconds and I am listening for 55 seconds, that means I'm only transmitting 5 seconds out of the entire minute. That is a different duty cycle as opposed to if I am transmitting 30 seconds out of the entire minute. And it's also different if I am transmitting all 60 seconds out of that minute. So my duty cycle is higher the more I transmit. So think of duty cycle as how much I use it. Another way to think about it is, well, I don't know if we have any chefs in the audience, but if you use, those hand mixers, sometimes you can use to mix batter if you're mixing cake, right? And sometimes if you read the manual, if you bother to read the manual, they'll tell you, 2 minutes off, 2 minutes on and 3 minutes off, right? You may have other equipment like chainsaws and other things that will tell you like that, 2 minutes on, 3 minutes off. Things like things to pump up your tire pressure. They may say 1 minute on, 5 minutes off. What they're telling you there is that's the duty cycle. If they tell you 1 minute on and you need to have 5 minutes off, if you only go and run that for 5 minutes continuously, basically you have exceeded the duty cycle rating of that device. In other words, you might mash it up faster by exceeding the duty cycle. So think of duty cycle as to how much of the total period that you could use for that you're actually using it for, right? So same thing with a transmitter. Unless you are a repeater or some dedicated device, you are probably not going to be transmitting all of the time. You might be having a low duty cycle, or you might be using some transmitting mode that has a high duty cycle. Yes, exactly. You want to prevent overheating. Correct, Colin? You spot on there with that. Because if you run a higher duty cycle, you're heating up this thing, it's getting hot, it might melt, it might burn out, right? Very good. So understanding material, yeah, very well done indeed. Okay, so what is the definition of duty cycle during the averaging time for RF exposure? So you're doing RF measurement. What is duty cycle? That is the percentage of time that the transmitter is transmitting. So if you're transmitting 10% of the time, 50% of the time, 100% of the time, that is the duty cycle, all right? What is duty cycle? Sorry, why is duty cycle one of the factors used to determine safe RF radiation exposure levels? And the reason is that it affects the average exposure of people to the radiation. In other words, if you have a higher duty cycle, you're transmitting for longer, that means you're exposing people to more radio frequency exposure. So that is why duty cycle is one of the important factors. So let's go to the next question and we will see an example of it. So it's a little bit of a long question, but we will deal with it quickly. Right, if the average time for exposure is 6 minutes, how much power density is permitted if the signal is permitted for 3 minutes and absent for 3 minutes, rather than being present for the entire 6 minutes? In other words, of the entire 6 minutes, you are only transmitting for 3 minutes, right? So the asking the question is, let's go again at it, right? How much power density is permitted if the, okay, let's read the whole question again. If the averaging time for exposure is 6 minutes, how much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes, rather being present for the entire 6 minutes? So what we're doing is using half of the time. So therefore, the answer will be 2 times as much, all right? So because it's 3 minutes present and 3 minutes absent, that is why it's half of the time. And therefore, if we are looking at the power density that we permit, we could actually allow twice the power density because we're only using half of the exposure limit, all right? All right, so at this point, the time is now 9:34. I think let us stop there, right? We have dealt quite a bit of the material. When we come back next class, we will finish off this section before we go into the next item, the next topic. So folks, we'd like to thank you very much for staying the course. Really appreciate all of the kind comments and the questions that we do get from time to time. We appreciate if persons could look over the previous sessions, look at the recordings, anything that's unclear. Please continue doing your practice tests, taking those practice exams that will give you confidence as to where you are. Several persons continue to take them, and I'm very impressed with your results. Very good indeed. All right, so our next class is expected to be on the Friday, the 14th of August. I'd like to urge everyone, please continue to be safe. We know what's happening outside there with COVID-19. We have a responsibility to do our part. Elections is up on Monday, and REACT, of course, is involved in respect of assisting with communications for elections. So REACT members who are in the class, wish you all the best with that exercise. And certainly all the persons in Trinidad and Tobago, please do enjoy your weekend and all the best for elections on Monday, the 10th of August. So folks, be good, be careful. Blessings, everyone. All the best. Do have a good night and take good care.